Finally, we're going to focus on the last learned objective, which is to determine if a data set contains outliers using the IQR. The IQR is the interquartile range, which is the length of the box in the box plot, and it represents that variability, which is the spread of the data. You can visualize the IQR by drawing a box plot. The IQR is the length going from Q1 to Q3, which is the length of the box. If you want to calculate the IQR, you're going to take Q3 minus Q1. That is going to give you the length. Now, we can use the IQR to find outliers. A data value is an outlier if the data value is less than 1.5 times the IQR below the first quartile, or greater than 1.5 times the IQR after the third quartile. In other words, X is an outlier if X is less than Q1 minus 1.5 times the IQR, or if X is greater than Q3 plus 1.5 times the IQR. Let's look at an example where we need to locate outliers. We're going to construct a box plot, and then we're going to highlight the area of the box plot that indicates where the outliers are located. This is going to help us visualize where we would see the outliers. Here we're given the 5-number summary. We have the minimum, the maximum, Q1, the median, and Q3. If we're going to locate outliers, we're going to need to find the IQR. The IQR is equal to Q3 minus Q1. In this case, Q3 is 13 and Q1 is 6. 13 minus 6 is equal to 7. Now that we have the IQR, we can find Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. Q1 is 6, so we should have 6 minus 1.5 times the IQR, which is 7. Again, here we're going to take 6 minus 1.5 times 7. This should give you negative 4.5. Next, we calculate Q3 plus 1.5 times the IQR. Q3 is 13, so we should have 13 plus 1.5 times the IQR, which is 7. Again, here on your calculator, you can enter 13 plus 1.5 times 7. This should give you 13.5. Here we're saying if you have an X value less than negative 4.5, then that X value is an outlier. If you have an X value that is greater than 23.5, then that X value is an outlier. So now let's go ahead and construct a box plot to help us visualize the area where we would see those outliers. I see that the minimum is 3 and the maximum is 39. So I'm going to start off at 0 and I'm going to go by 3s. Notice I went from 0 to 42 to ensure that I capture the minimum and the maximum within those values. I could also go from 3 to 39. I just like to have a little bit of space on the left and right before the minimum and after the maximum. Now let's go ahead and construct the box. The minimum is at 3. The maximum is at 39. Q1 is at 6. Q3 is at 13. And the median is at 12. Go ahead and create the box going from Q1 to Q3, and then draw a line going from the minimum to the box, and then from the maximum to the box. Here I'm not going to take the time to write a title for the x-axis and a title for the whole plot because we're not given any information about where this data is coming. But in general, if you're going to construct a box plot, you need to have titles. A title on the x-axis, a title for the whole plot. Here, our main focus is to identify the area where we would have outliers. If we have any data values below negative 4.5, they're considered to be outliers. So let me label more values here to the left of 0. Negative 3, negative 6, and negative 9. If we have any data values below negative 4.5, then those data values are considered to be outliers. Here, we don't have any values below negative 4.5. Notice the minimum is 3. That means that the smallest value in our data set is 3. Now, here on the right, if you have any data values above 23.5, then those are going to be outliers. Here, we see that the maximum, which is 39, is an outlier. Is it possible that we have more outliers? Yes, it's possible. Why? Because 25% of the data values are between Q3 and the maximum. So it could be the case that we have more data values above 23.5. However, we're not sure. We only know that x equal to 39, which is the maximum, is an outlier. So if you're wanting to find outliers using the IQR, you're going to need to compute the IQR. You're going to need to compute Q1 minus 1.5 times the IQR. And you're going to need to compute Q3 plus 1.5 times the IQR. Once you compute these values, you're going to have a lower bound and an upper bound. You're going to say, if I have any x values below Q1 minus 1.5 times the IQR, or if I have any x values or data values above Q3 plus 1.5 times the IQR, then those are considered to be outliers. Now I'm going to let you practice this on your own. Go ahead and consider the data set below. What values would be considered outliers? Below this video, I'm going to ask you to enter the value of the IQR. I'm going to ask you to enter the value of Q1 minus 1.5 times the IQR and the value for Q3 plus 1.5 times the IQR. Finally, I'm going to ask you if you have any data values that are considered to be outliers.